Hello, this is Scott. So today we're talking about Pareto analysis for circuit defects. So in general, a Pareto chart, which is the cornerstone of this analysis, is a histogram of some variable of interest plotted by categories. And it's named after an Italian economist, Pareto, who basically did a study and determined that 80% of the land in Italy was owned by about 20% of the population, and this carries across into very many industries, specifically defects, where it could be determined that 80% of the defects are normally generated by only 20% of the process itself. So we're using for this illustration, we're using a data set out of Montgomery, a quality control guru in the United States. I believe Arizona State's where he came from. Anyway, he's written several books. We're using a simple circuit analysis data set here, and actually generating the charts within Statistica. So if you have Statistica, you have this data set within the examples folder. It's just circuits is the file name. So I'm going to illustrate using quality control. Under quality control charts, there's this Pareto chart analysis, and there are different options that are set up here. The data here is actually aggregated counts. So I'm going to click on this radio button here, and then we only have one variable name. So that's going to be my setup. I'm going to click OK, and boom, I've got a Pareto chart. This particular title is not very specific. So, and by default, it uses the variable name. So I could put in, Pareto chart or Pareto analysis. I could spell for circuit defects, and include this header in the project line. You've got different options here, shop for. So there's a lot of different options that we won't be going through. But it did update this here. I can also double click on this column. I can, modify the header itself. I'm just going to delete this. And there we go with the Pareto analysis. So one of the things that we can see right off the bat is that there's a large percentage of these errors that are defects that are generated from a small proportion of the manufacturing process itself. So what we might want to do is actually generate the percent here. So if we click on, let's see, under quick, the options, I'm sorry, it's not under the options, it's actually under this main tab right here. So show the percent to label, and then if I click on update to update the chart, I can see that the bars now change from units to percentages, and I can see that 40%, 20%, and 7% have come off of these first three categories in the manufacturing process. So about 68, 69% of the problems are related to these three. I could also get a chart summary, and then this will actually give me the cumulative percent. So I can see that the first three, which are all solder operations, contribute about 68.4% of the defects within those three. We have a total of 16 categories. So 25% would be the first four, about 75% of the value. So not exactly 80%, but certainly a high number here. So I think I'll keep it pretty short this time. That's just a quick introduction into a Pareto analysis where we determine the percentage of defects with a short number of manufacturing categories. This was S75, part of the hands-on Statistica series. You can send me an email if you have comments or want to see something particular. Thank you.